Hello, Geography 231 students, and welcome to your week 4 tutorial. So this week we're going to be getting into census data. I prefaced it last week saying that we were going to wrap up using Understanding GIS, the textbook for now, and we're going to move into learning about census data for the next 2 weeks. So that begins today. So this is your tutorial. You've got a lecture online as well, and then a lab that was carefully crafted with love and tenderness by myself. So I've been working with census data for a very long time, and so I just decided to build out a lab on my own that I think teaches the skills that I want you to learn this first week, and then next week we'll get into some other skills as well. So without further ado, let me introduce this week's lab. I'm just calling it Working with Census Data. It's obviously available on Canvas now, so you can download that, which you've probably already done. And so basically I will read these first two intro paragraphs so that you get some gist of what we're talking about. So in this GIS lab, your goal is to create two maps displaying the median household income data, one for Orange County, California, and the other one for the entire United States. You will search for and download census data and GIS boundary files from the U.S. Census Bureau. You'll format the tabular census data for use in GIS. You will join the tabular data and the spatial data together in GIS. You'll symbolize the features using census-derived attributes, and you will create two map layouts, one for Orange County and one for the United States. Finally, you will answer 5 questions about the visual distribution of median household income in Orange County and in the United States. So at the end of the GIS lab, you also have some questions to answer as well, and you'll just type in your answers in the Canvas area for week 4. So census data are tabulated and aggregated at many different geographic levels. The smallest level is a census block. In suburban Southern California, census blocks tend to contain about 250 people, which is about the size of an average neighborhood block in SoCal. The next size up is an aggregation of blocks. It's known as block groups. Those tend to average about 1,000 people. And then next up from that is the census tract, which is the term that I think most people are most familiar with. Tracts tend to be a common geography you'll see in the media and things like that. Tracts tend to average about 4,000 people. And I don't have this written here, but just one bit of information about census geographies. They really are formed based off of population size and not geographic size. What that means is that if you've got an area with a very, very low population density, you might have a census block or block group or a tract that's very, very large compared to the average. So like in we'll say Nevada area, maybe Utah, desert places without a lot of people, you'll find census tracts that are the size of counties or larger. And that's because it takes that much area to collect enough people to equal the average size of a tract. So just be aware of that. If you're looking at census geography data, you'll see some tracts that are very huge and others that are very small. And so it has less to do with the physical size and everything to do with the total population within those tracts or blocks or block groups. Okay, so you can pause this now if you want to get out your web browser, because the first thing we're going to do is download the data from the Census Bureau. And so what you will do is navigate to data.census.gov. I'll pull that up real quick. Oops. So data.census.gov. Next thing you're going to do is click on Advanced Search. And then here from this point, you can either browse for topics, you can enter keywords up at the top, or you can go straight to selecting your geographies, meaning if you're looking for data at the tract level, you can choose that in geography. If you're looking for state level data, national data, block level data, you can do that first. So you can approach it from either the topic of the data first or the area. You can also specify the years. And then if you understand your census data well, you can also specify which survey you're looking for. In our case here, we're going to be looking at topic first. So go ahead and click on topic, and then income and poverty. Click on income and poverty, and then just put a check here for income and poverty. Okay. Don't click search yet. We're now going to specify our geography, our geographic units. So click on geography, and we're going to first pull the block groups for Orange County. Obviously that's in California, so we're going to choose California, and then just Orange County itself. The default up here is all blocks within California. We don't need that. We just need Orange County. Okay, then all block groups within Orange County. Let's go ahead and select that, and then search. And then these are all of the different data tables that are related to income and poverty. Okay, so we have a lot. It's actually, you've got 123 tables you can choose from. Luckily, ours happens to be in the first page of results. We want median household income in the past 12 months in 2018 inflation adjusted dollars. Shorthand for that, the table code is B19013. So that's right here, B19013. Okay, so if you have fewer geographies, meaning fewer geographic units, you'll usually be able to get a preview here, be able to see what the data looks like. But because there are so many geographic units, in this case over 1,800 for Orange County, you just have an option to download the table. So I'm going to go ahead and click on Download Table, and then a couple of settings to verify. So this is, again, to confirm, table B19013. That 5-year tells you that this data comes from the American Community Survey, the ACS. The ACS is constantly polling people and also taking what they call small sample size census data. And so the American Community Survey takes the decennial data, which is collected, as the name implies, every 10 years, including this year, and then they will extrapolate out from the full data set yearly data based off of small sample size polling. And so ACS data 5-year is often a 1 in 6 count poll. And so we've got ACS data going back to 2013. The American Community Survey just started in the last 10 years. And 5-year, meaning it's a 5-year average ending in 2018. So 2018 data includes the years 2014, 2015, 2016, 2017, and 2018. Okay, so it's the answer to this question about median household income averaged out over 5 years. All right, so we confirm that we're going with 2018 data, confirm your file type is CSV, and go ahead and click download. It's going to say we're preparing your files, and then once it's done, go ahead and click download now. Okay, I've already done that, so I'm not going to download it again. All right, but make sure that you check your downloads folder. That's where this data will eventually end up. Your downloads, okay, and a lot of the file names are a little bit confusing to understand once you've downloaded them, but just know that the first letters there are ACS, American Community Survey. DT, I believe, is the one. I don't know what it stands for, but 5Y is 5-year 2018. Then after the period, that's where you see the file name, B19013. And then this is just the date and time when you download the data. Okay, so the key thing you want to look for is these letter and number combination there after the period. All right, so you can just download your data. Don't cancel. You download yours. And then once it's downloaded, go ahead and click on the United States Census Bureau icon up in the upper left to return to the home page. And we're going to start over again, but this time we're going to download data for the full United States at the county level. So we're going to go ahead and click on Advanced Search. And then we will click, and this time we're going to do geography first instead of topic. So geography, county, and then all counties in the United States. Okay. All right, this time don't click search yet. We're going to scroll up to the top and actually, you just go ahead and put your cursor there in the search box and then type in S1903. S1903 is another data set. In this case, it's a median income in the past 12 months at the county level. Okay, so it's a very close comparison to what we just downloaded for the local block level, or block group rather, but this is going to be at the county level. So the first return is one you want because it's in 2018 inflation adjusted dollars. Okay, let's go ahead and select that, and then confirm that the years here. Go ahead and click on years. Make sure that 2018 is selected. So select 2018 and close this box here, then click download table. And then it's going to try to give you two different data sets, 1-year and 5-year estimates. So again, these both come from the American Community Survey. And as I showed you before, they started aggregating the data in 2013. But also, in addition to there being 5-year estimates, there are also 1-year estimates. For larger geographic areas like counties, we see every year the data gets produced by the Census Bureau. With cities, only certain larger cities get aggregated every year. Usually there's about a threshold of 60,000 people. If it's a city of fewer than 60,000, then you're only going to see 5-year estimates. If it's larger than that, then you're going to see 1-year estimates. But these are counties, so these are going to be bigger anyway. So just uncheck the 1 year. So make sure it's only 5-year estimates, CSV file, go ahead and click download. And again, I've already done this before, so I'm not going to download a second time, but go ahead and click download now. And the data will be downloaded to your downloads folder. All right, once your data gets downloaded, then we are going to now collect our geography files. In this case, I actually already have the tab open, but I'll navigate there to show you how to find the data. So when it comes to pulling census data into GIS, you have to have, there are 2 components. Component 1 is what we've just gone over, the tabular data, the actual count numbers, the numbers of people by, age, sex, race, whatever, income, variables, all that. There's that, and then there's the actual GIS shapefile component. So the feature classes or shapefiles, you bring those into the GIS, and then you join those with the tabular count data on what's called a GeoID field. It's just a unique identifier that is in both the tabular data and the spatial data. So they have a matching field, and that allows you to do an attribute join in the GIS. So we've got our tabular data, and now we need to get our GIS data. So open up a new tab in your browser and do a web search for census tiger /line data. Hit enter. Then it'll be your first search result in Google, tiger line shapefiles, Census Bureau. Go ahead and click that. And now we are going to just scroll down the page a little bit below 2019. And if you're seeing this video in the future, then you're probably going to see 2020, 2021, whenever you're pulling it, whenever you're seeing this. Just scroll down, assuming that the Census Bureau website doesn't change too much in the future. I'm sure it will. You're going to go down below download and click on web interface. All right. Okay. So web interface, this now allows you can either access it this way or through an FTP. It's just more user-friendly to go through the web interface. So the first thing we're going to do is find block groups. And again, these are geographic boundaries for block groups. So if you were to look at these data in GIS, all you would see is a unique identifier, like you'd see the block group number, because every block group has a unique code that tells you what essentially what the address of the block group is. But that's about it. You wouldn't see any count data. You wouldn't know how many people live in that block group. You wouldn't know anything about those people at all. So you have to, that's why the count data, the tabular data, are one of the required 2 components. Okay, you need both to be able to do anything spatial analyst wise. Okay, so year 2019, that's the current. These you'll see that there are years going all the way back to 2007. The only time these boundaries change drastically is every 10 years, every decennial census. But on a year-to-year basis, the Census Bureau is cleaning up data. They're basically fine-tuning boundaries. They're making them more spatially accurate, more representative of what's on the ground. So you just take the most recent boundaries to make sure that you're getting the most spatially accurate data. And then for select layer type, you're going to find block groups. Hit submit, and then we're going to go to California, obviously, and then download. So there is no option to only download the block groups for a county, okay, at least not yet. So you're going to do the entire state of California, and then later on in the tutorial, I'll show you how to pare those down to just those that are in Orange County, okay? So go ahead and hit download, okay? And then once you have downloaded those data, again, I've already got them. Once you've downloaded those data, go ahead and click on main download page, okay? To bring you back to where you were before. Then keep the year at 2019 and then change the select a layer type to counties and equivalent. Counties and equivalent. You might be asking, what's the equivalent of a county? Well, if you live in Louisiana, they have parishes. If you live in Alaska, they have, I don't know if they're called parishes, but they have a different name because they're huge, like the size of a state. And so not every county in America is called a county, but there are certain equivalencies in other places. A parish in Louisiana is the equivalent of a county, essentially. So go ahead and download that. And then once we've got that, we're then just going to go into your downloads folder, and then we're going to unzip all these files, right? So we have unzipped, I'm sorry, we haven't unzipped anything yet. We're going to open up the county, the block group data first, okay? So again, you want to look for that file name that has the ACS, American Community Survey, 2018 5-year, .B19013. Go ahead and open that up. And the only file you're going to need is this underscore data with overlays. Okay, the rest are metadata and then table titles. So those are kind of supplemental data. You don't need them. Okay. So just go ahead and extract those data into a location on your C drive. Okay. So go ahead and do that now. And then once those are open, I've already got mine. Let me pull mine up. All right, once those are open, then we're going to move on to the next steps here. So following along in your lab assignment, this is after field header, format household income block group data for join, and we are now at step 2. So format fields for attribute join in GIS. So there are quite a few formatting steps you need to take. Whenever you download data from the census, you end up with 2 different field headers for every column. You'll end up with a short coded name that works okay in GIS, and then you'll end up with a very long name that's descriptive that tells you what the data is that you're looking at in that particular field or column. But you really need to get rid of that long descriptive name before you bring it into the GIS. Okay, so we're going to do partly that. We're going to format the GeoID field so that we can match that up exactly with the spatial data, and then there's just a couple other cleanup steps that we're going to take. So you can follow along with me, or obviously you can follow along in the lab at this point. I'm going to walk you through a few more steps together, and then I'm going to skip ahead in this tutorial to the cartography aspect. So you're going to want to probably just put this video to the side. So let's format this Excel sheet together, and then you'll do the next one on your own. Okay. All right. So first thing we're going to do is click in cell C1. And I don't have this in the lab, but I'm going to maximize these column headers a little bit, or fields, so we can actually see them. Okay. All right. So in field C1, we're going to replace the official field name, the B19013_001E. We're going to just call this HH income with an underscore. Okay. Remember, no spaces in field headers. Household income, HH income. Okay. And so just so you know, field headers are really limited to 64 characters if you're going to be joining them in GIS. So you got to make sure that they're under 64, which is a lot of characters. You should be fine, but just be aware of that. So that's why you can't keep these really long descriptive names like estimate median household income in the past 12 months, blah, 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 blah. Okay, so we're just going to call it HH income. Next thing we're going to do is delete column D. We don't need it. This is margin of error data. If we are going to be doing a really high-tech spatial analysis or statistical analysis, then we need to keep the margin of error data, and we will be getting into that. But for now, we're going to get rid of that. So right-click it and delete. Okay, so now we just have 3 columns. And now we're going to get rid of the long descriptive field headers. So right-click row 2, delete. And so now we have our data, and we have our original column headers. Next step is we need to truncate the GeoID field. So all we have are the numbers after the letters US. So these are basically all coded. This is all one long big code to tell you what block group you're looking at. And I can even break it down for you here before we delete anything. So I can't actually tell you what the 1500000 is. I'm not sure. Something to do with the census. Then we got US. Okay, obvious. United States. 06 is the FIPS code for California. Okay, so every state and territory of the U.S. has a 2-digit FIPS code. Okay, California's happens to be 06. It's pretty much tracks with alphabetical order. So Alabama, Alaska, Arizona, Arkansas, California. That should be 5. So there's some other territory in there that I'm not thinking of right now. So 06 is California. 059 is Orange County. So every county in California has a 3-digit FIPS. 059 is Orange County's. Then 0320 is the first. Those are the first 4 digits of a census tract. So 0320, and then 0.49. So it's the full thing. 032049 is the census tract, and then within that census tract is block group 3. All right. And so if you were to have the full block data, you would have this whole thing. And remember, blocks are smaller than block groups. So they have actually a longer code because there's more detail involved. So it's 06 California, 059 Orange County, 032049 census tract, block group 3, and then you'd also have, it's actually a 4-digit code for the block. So you'd maybe 0001 to tell you it's block 1 and block group 3. So anyway, just know that. That's what these GeoIDs are. They're basically an address. And the longer the code, the more specific the geographic unit. Okay. All right, so we need to get rid of everything up to after the US. And so to do that, we use a tool called text to columns. All right, so before we do that, we need to insert a column, and that's to give us space to expand. So we're going to right click on column B, insert. Okay, now put your cursor here in cell A2, and then the shortcut is hold down Shift and Control and press down on the keypad, and that will bring it'll allow you to select every single cell from where you inserted the initial selection down to the bottom. Okay, so we've got them all selected. Now click on the, and if that doesn't work for you for whatever reason, you can just click and drag or hold Shift or whatever. It's 1,824 rows down, so it's pretty long. So that's why I use shortcuts to get there. So go ahead and click on the Data tab. And then in the Data Tools group, go ahead and click on Text to Columns. And then we're going to do Fixed Width. So delimited looks for certain types of characters like commas or semicolons. Fixed width actually lets you choose the width where you're going to be cutting a long string of text. Okay, you get to choose a line break. So you're going to do fixed width, hit next, and then you just click in here where you want to create the line break. So after US, go ahead and put a click there. Now if you accidentally click over here, for example, you can drag it, okay, into place. And if you create a whole bunch, you can just double click it to make it go away. But ultimately, you want to have that line break after 1500000 US. Create a line break, and then the important thing is to make sure that that 0 gets preserved. And so I'm going to show you how to do that in a bit. So go ahead and put that line break in there. Hit next. Now to preserve that 0, you have to select. Notice how these have these little data preview headers, general, general. Now with general, this 0 before the 6 is going to get wiped out. It's going to go away. We don't want that because in the GIS data, that 0 is there. And as I said before, you need the tabular data and the GIS data to have an identical match in a GeoID column. So you have to preserve that leading 0. So to do that, you select both of these columns before and after the line break. And then for column data format, select text. Text will maintain that 0 because it doesn't look at it as a number 0. It looks at it as a text. Okay, so we're going to do that, and we're going to hit finish, and then it cuts it off, creates a line break, and moves over all the text after the line break into a new column. Okay, so let's go ahead and copy, cut and paste the GeoID field header, paste it right here, and now we can scrap, get rid of everything that was before that. Or up to that US. So select column A, right click, delete. Okay. All right, we are almost through the first one, but the last thing I want to have you do is you'll notice here in row 22, there's a hyphen. Okay. The GIS does not know what to do with a hyphen. So what you're going to end up with is just a kind of a non-conforming GIS feature type. And so because ultimately what we're creating is a choropleth map or a graduated symbol color map rather, we need to make sure everything is a number, whether it be 0 or something else, it has to be a number. So we have to get rid of all those hyphens. Well, you could go through, you can either sort the fields and find them all, or we can do just a shortcut where we're going to select all of the cells by you click in cell C1, sorry, excuse me, C2, do a Shift Control down, and then Control H, which is find. We're going to find, actually it's find and replace. Okay, so Control H, we're going to find every hyphen, and we're going to replace it with a 0. All right, so we do that just so that every cell has an integer in it. There are no special characters. So replace all, made 27 replacements. So 27 hyphens got pulled out and replaced with zeros. So do that, okay, and then lastly, we're going to do one more search. In this case, there are also block groups where the median household income is so high that it's over 250,000. And so rather than getting all the individual median household incomes by block group, they just lump all the high income block groups into 250,000 plus. Okay. Unfortunately, that plus makes it a non-integer. It makes it a text field. So we have to find those. Okay. So we're just going to type in 250, 000 plus and replace that with 250, 000. And that replaces the text cell with a integer and replace all. So 9 replacements were made. Close. Okay, so that's all the data prep we need to do for this Excel file. So what you're going to do is go File, Save As, and save it into whatever folder you're currently working in. Okay. And I'll just keep mine in the same folder, but you want to make sure the type is Excel workbook. Okay. So I've already done this, but I want you to call it OCHH income. That's Orange County household income. And then make sure that the save as type is Excel workbook, which will make it the latest and greatest Excel format, which is .xlsx, and hit save. All right. And then you'll basically do a save as, and then you will be able to then add that data into ArcGIS Pro. Okay, so do that. And then I want you to do this, all the same steps. This is in the lab itself. I want you to go ahead and repeat all these same steps, move on to the next section, format household income county data for join. Do that. I'm not going to walk you through it because the steps are the exact same as what we just did. All right. So I want you to go through, replace the field headers, do the truncation, all of that. Okay. Once you're done, you can go ahead and pause the video. Once you're done, we're going to pick up at the GIS portion of this. All right. Let's go ahead and pause now while you finish it up. Okay, welcome back. So now I assume you've finished formatting all of your data and your results look the way that they should based off of the actual lab assignment itself. Okay, so now where we're going to pick up is in ArcGIS Pro. So go ahead and open up the software, make sure you're logged in, and then go ahead and create a new map. And for the name, let's call it Census _data, and then just save it to whatever your location is where you've been working. I would recommend, if we were in class together, I would have told you this already, but I would recommend creating a folder. Usually it's in a USB drive if you're in the lab at Cypress College, but if you're at home, just a folder on your computer and just call it GEOG 233 or something like that. That way you can save all of your work in one place. Okay. All right, let's just make sure that it's named census data, save it in a logical location, and go ahead and hit OK. And once that's done loading, the first thing we're going to do is change the name of this map, which is always just called by default map. We're going to change it to Orange County HH income, Orange County household income. So you just click with your cursor over the name map, leave your cursor there for a second to make it editable, and Orange County HH income. Another way to do this is in catalog, maximize maps, and then you'd see the word map in here, and you could right click and hit rename and do it in there as well. The same results. Okay. All right. Okay. Next thing we're going to do is change the coordinate system for this map, because right now it's just in a geographic coordinate system with degrees, minutes, seconds. We're going to change it to a local state plane projection. So go ahead and double click on Orange County HH income to bring up the map properties. Click on coordinate system, and then do a quick search here in the search box for California and hit enter. And that will minimize it down to only projected coordinate systems that have the word California in them. So maximize projected coordinate system, state plane, NAD 1983 US feet. And there are multiple versions of this, and you could, if it were up to you, you could choose a more recent one like HARN 2011, 2011, HARN 2007, one of those, which is a little bit more recent. But most GIS data in Orange County is still NAD 1983 US feet. So we're just going to go with that one. And Orange County is in Zone 6. So it's NAD 1983, State Plane, California, FIPS 0406. All right, so 04 is California, and this FIPS has nothing to do with the Census Bureau FIPS. This is something else. And 06 is the state plane for Southern California, Orange County, also San Diego. Let's go ahead and hit OK. And you're going to see the map change. Visually, it's going to look a little slanted now with this scale, but if you zoom into Orange County, it's going to look real good. But before we do that, we are now going to add data to our map. And I don't think I mentioned this before, but you want to make sure that you unzip those shape files. So I think I need to add that to the tutorial, but make sure that you take a moment to unzip the shape files if you haven't already done so. So you save them onto your C drive, preferably in the same location where you saved your census data. And then just go ahead and click on the map tab, add data. And you're going to navigate to your folder where your spatial data is located. Oops. All right. you don't need to follow the location. This is just where I happen to put mine. So you're going to add both of them for now. Okay, so we'll do TL 2019-06 BG stands for block group. 06 is Orange County, BG is block group, and then US counties. Go ahead and hit OK. And so both layers are in the map, but we can turn off county for now because we're going to focus on block groups. So go ahead and turn off county, and I right-click on the BG layer and click on Zoom to Layer. Now you can see that California actually looks pretty good in State Plane Zone 6, right? Better than the U.S. as a whole, and that's because it's closer to the actual point of distortion, the point of least distortion here in California. All right, so we're going to query out only block groups that are in Orange County. I'm going to right-click on BG, Properties, Definition Query tab, and then we're going to do a new definition query. This new definition query will be county FIPS, so COUNTYFP, county FIPS. And FIPS is an acronym that stands for federal, I think, I actually don't know what it stands for, but it's like a federal tracking system, okay? And we want 059 for Orange County. Go ahead and hit apply and hit OK. You're going to see that full data set. A lot of it's going to go away, and you're only going to have Orange County left. Let's go ahead and zoom in. Kind of nice and tight there. And so we've now queried only Orange County block groups. And then the next step I want to do is actually project this layer. So right now we just have a subset of a larger data set, but we don't need all the block groups that are outside of Orange County. So you could do a right-click, data, export features, which would give us just the block groups in Orange County, but they would still be in their original geographic coordinate system. But we want them in state plane coordinate system, so we'll just do that instead. So we're going to project the data. So click on the Analysis tab, click on Tools, then do a search for Project. Spelled the same as project, right? And then select Project Data Management Tools. This projects spatial data from one coordinate system to another. Go ahead and select. For our input, we're going to choose TL 2019-06 BG. For the output location, just put your cursor in this box. You don't need to hit the Browse button because it will automatically select the default geodatabase that was created when you created this project, which is for you and for me, it's going to be called censusdata.gdb. So put your cursor in there, and there it is. There's censusdata.gdb, and then after the backslash is the original name, and then it just appends _project. But we're going to change that name to OC block groups. OC, and never forget your underscores, block groups. Remember, just like in ArcMap, you have to have block groups. You have to have underscores. All right, next thing we're going to do is give it an output coordinate system. My dog, apologies. Okay. So hit the drop down anyway, so I was distracted by my dog barking. If you hit the drop down, since we set the projection for the map, you can hit the drop down and then click on current map, Orange County HH income, and it will just pull the projection from the map frame itself. And so there it is, State Plane, California, FIPS 0406. That's what we want. You can leave geographic transformation and preserve shape blank. Just leave those alone. Go ahead and hit run. And it will project the data and create a new feature class at the same time, which is exactly what we want. Okay, and it takes the same color from the original file, which is just it's kind of a quirk of ArcPro. Let's remove the TL 2019-06 BG. We don't need that anymore. All right, and then now is a good time to save your work. So go ahead and click on Save. So to confirm that you only have block groups for Orange County, go ahead and open up the attribute table, and there should be 1,823 block groups. And sure enough, there are, so that's good. Okay, so you're going to repeat those same steps for the U.S. counties layer as well. Okay, well, they're not the exact same steps. You don't need to project the counties layer, but just go ahead and move on to the next section without me. Okay, I don't need to walk you through it. Essentially, what you're going to just do is make an export of the counties layer and give it a new name. It's going to be called USA Counties. So go ahead and do that. You can pause the video and take care of that, and then start it up again. And then we will pick up at the step after that, which is create a new map for the national county level data. Okay. All right, so your map should now look like mine. Okay, now we're going to create a new map for the national county level data. Excuse me. So click on the Insert tab. We're going to go in the project group. We're going to go New Map. You can just click on the icon itself. You don't have to click the drop down. So that creates a brand new map. And now we're going to add the USA counties level that we just created from the previous map into this one. So let's go ahead and right click, copy. Then go back to the map tab here, right click, paste, and let's rename this map. We're going to call it USA HH income, just like the other one's Orange County income. We're going to call this one USA HH income and hit enter. All right, so we have two maps, Orange County HH income and USA HH income. In the Orange County map, you can remove the USA counties because we're not going to need those there. Back on the USA HH income map, after you remove the counties layer from the Orange County map, in the USA income map, I want to just draw your attention to the spatial inaccuracy of like the state of Alaska, for example, and the United States in the north. So Alaska is very big. It's the biggest state in the country, but it's not that big. So that tells you that the map projection is, it's actually like a Mercator geographic projection right now, and it makes the U.S. very distorted. It gives you an inaccurate reflection of what the country actually looks like. So we don't need to project the county level data, but we are going to set a coordinate system for the map itself. So let's go ahead and do that. Let's double click on USA HH income to bring up the map properties. Make sure coordinate systems is selected. And then in the search box, go ahead and do a search for USA contiguous. All right, so that will find coordinate systems, projected coordinate systems with the word USA contiguous in them. So click on the little expand arrow there, continental, North America. And then we want USA contiguous Albers equal area conic. So it's a mouthful, but it makes a nice, accurate depiction of the contiguous USA. Now, there are other projections for Alaska and for Hawaii and other territories outside the contiguous US, but because we're only going to be making a map of the contiguous US this time, we're going to go with this projection. Let's go ahead and hit OK. And now Alaska looks a little funny, but the contiguous US looks pretty good. So you can either right click and drag to zoom in, or you can hit shift and drag a box around to make it kind of nice and tight here in the map frame. Sort of center it just like so. And now is a good time to save your project. Go ahead and click save. All right. All right, I'm going to walk you through two more steps, and then you'll do the rest on your own. So I'm going to bring you through the next section, which is join Orange County block group geographic boundaries to tabular census data. This is where we're going to actually join the block groups to the census data we downloaded. So back on the Orange County HH income map, we are going to right-click on OC block groups, go to joins and relates, add join. For the input field, that will already be by default the OC block groups layer because that's what we right clicked. The input join field, now this is that unique ID field I've talked about. This is where you need to have an exact match in the GIS data as well as the tabular count data. So go ahead and choose GeoID. And the names themselves don't have to match. Like you could have GeoID and you'll see that the other table will have geo_ID. It could be called Ian if we wanted. It doesn't have to have the same name, but the data within those cells, within those columns rather, need to be identical. Okay, so as long as the data are the same, the field headers don't matter. So now we're going to find the table, the one that we formatted together just a moment ago. So in this case, go ahead and hit browse, then navigate to where that data, those data are located. In my case here, I've got a kind of a roundabout way I have to go, but hopefully yours is a little quicker to get to. So find the data sets that we were just working with. Here's mine right here, OCHH income. You're going to actually double click the file name and then choose, this is actually a worksheet within that Excel file. And so it'll be that long name from before. The key letters you want to look for are B19013. Hit OK. Then it's going to ask you for a join table field. So in the join table, which is the census count data, you also, as I said, need to have the matching GeoID. So it just so happens this one is called geo_ID. Go ahead and hit OK. And the joins are pretty quick, shouldn't take too long. But you're going to want to verify that the join was successful. So right-click on OC block groups, open up the attribute table, and then scroll all the way to the right. And first you're going to see all the data from the actual block group GIS shapefile. You've got the block group name, a couple of other data points there. So scroll over to GeoID. This comes from the census tabular data, name, and then HH income. That's the data we really need, right? So household income. Also, all those data points have now been added or joined to the block group GIS files. All right, so you can close the attribute table. Go ahead and save your map once that's done. And then carry on and do the same join that you just did here, but do it with the USA data. So just follow, go to the next step in the lab, take care of the USA counties, do the join there to the county level income, and then we'll pick up here at the symbolized data in just a moment. All right, for the last step of this tutorial, but not the last step of the lab, I'm going to walk you through how to symbolize the data in ArcGIS Pro based off of the household income numbers. Okay, so in the Orange County HH income map, we're going to make sure that OC block groups are selected in the contents pane, and then click on the Appearance contextual tab. And I've got a note in there about what contextual tabs are and how they're different than regular tabs, and basically they appear in certain contexts. In this case, the context means that you need to have a layer selected in contents pane, which we have. So click on Appearance and then click on Symbology. And then you've got all these various ways of symbolizing. You've got single symbol, unique, graduated symbol, bivariate colors, dot density, a whole bunch of different ways. We're going to go with graduated colors because this is going to be a choropleth map. And then it's going to ask you what field do you want to draw those graduated colors from. It's going to be HH income, so only numerical fields are available. So HH income is numerical, which is good. We're going to leave normalization as none. We're going to leave method natural breaks. We're going to leave the classes as 5. And then for color scheme, we're going to change it to yellow, green, blue. All right. So you can either look for something that looks like yellow, green, blue, like from the lab, or if you right-click, I'm sorry, that's an ArcMap thing. You can't right-click. You hit the drop-down, then click on Show Names. So now we see all the names, and we're looking for, it just happens to be in alphabetical order, conveniently, yellow, green, blue, yellow, green, blue, continuous, specifically. Yellow, where are you? Yellow, green, blue, continuous. Oh, you know what? Yellow, there it is, sorry. Okay, yellow, green, blue, continuous. Okay. Make sure I get that right. Yeah, all right. So we've got that here. And so we have got the symbology set, but we're going to take care of the class values. We're going to change the values to something a little easier to digest. So we see these very specific values: 58,359 for the lowest value, 171,618 for the second highest. So those are because those are based off of Jenks natural breaks classes, which basically looks at natural breaks of the data. It's very useful, but we want to pick something a little more logical to the eye. So when you see it, you're like, oh, okay, I understand those classes. So we're just going to kind of round. So we'll first change this one to 60,000. Remember, this is median household income. This isn't individual income. This is the total median household income for houses. So 2 working adults, it will be their combined income. We're going to change class 2 here from 89,671 to just 90,000. I'm going to change this 123,068. I'm going to round that up to 125,000. I'm going to change this 171 to 175,000. It's a pretty big jump, but it works out okay. And then we have to leave the last one as is, because as you saw earlier in the lab, essentially the highest incomes were just all grouped together as 250 plus. So there could be some census block groups like along the coast or in South Orange County where the median household income is like 350,000. Well, we're going to lose that data. It's going to get kind of washed out as it's all grouped together as 250 plus. All right, last thing we're going to do here is change the labels. And this is a little time consuming, but first thing you want to do is just get rid of all those zeros after the decimal place. You're going to add a $sign and then a comma. So you're like 60,000. Okay. So I'm going to get this all prepped. You don't need to watch me do it. We'll pause the video for a second, then we'll pick up again. All right, so all of my classes are now set. So the last thing I'm going to have you, last thing I'm going to work with you on here is you're just going to want to change the transparency, and that's because you're going to want the layer below to show through. So we're going to change the transparency to 25%. You can either drag it to 25, or you can just put your cursor in here, double click, enter 25, hit enter. So we've added a little bit of transparency, and we're going to change the base map to terrain with labels. So back on the map tab, base map, terrain with labels. And that way we get some city names. You also still get the topography. And yeah, so it's a little noisy at this scale, but there we go. It's a little bit better. Okay, let's go ahead and save there. So repeat the steps for the national map. Make sure that you follow the lab exactly because the color scheme is a little bit different. After that, you're going to create two map layouts. So that's basically the maps for exporting to PDF that you will upload to Canvas. And I've got full instructions on that. And then you will answer 5 questions at the end. Okay, so those questions, you're going to put your answers in the Canvas text box. But that's also here included in the lab as well. So that concludes the tutorial. I know I skipped steps, but that's just because there's a lot of repetitive action here. I want you to learn these steps. So that's why I'm having you do 2 different maps. We're basically doing both steps 2 times. Okay, so that was the whole purpose of that, but I don't need to walk you through it both times. You just need to do it yourself. So go ahead and finish that up. You have a week to do these, export them to PDF, upload the 2 maps to Canvas, and answer the questions on Canvas as well. And that will do it for this week's lab assignment. Have a great one until we speak again. Goodbye.